Okay, so now we're going to go ahead and start section 1.2, which is on angle measures and angle bisectors. So for section 1, we have the following vocabulary words. An angle. An angle is a figure formed by two rays with the same endpoint. So we already learned the definition of a ray is an endpoint and kind of like this little arrow thing. So there's one ray, here's another ray. They're connected by the same endpoints, and that creates an angle. Vertex is going to be the common angle. So this is the angle. This point right here is a vertex. And the sides are the ray. Okay, so if I want to go ahead and label this particular problem, let's say I have P, Q, and R. So my angle would be angle P, or I could also call it angle QPR, or I could also call it angle RPQ. Angles can be listed several ways. You either have to have 3 letters or just the one to notate that angle. The vertex would be P, point P. And the sides would be PR and PQ. Those are angle, vertex, and sides. So we're going to go ahead and do example 1. I kind of explained it in my definitions on the last slide. This is just name the given angle. So there's a few ways to do this. So first one, I could write it as angle K. I could write it as angle 1. So sometimes they put an angle value on the inside, so you can also label it that way. I could also label it angle LKJ. Just be careful that when you are using the 3 letters that you're going in the correct order. Basically, your middle letter should always be the actual where the angle is located. So the other way I could use 3 letters is going the opposite direction. So J, K, L. And all of those are correct ways to represent the given angle. Next one we have acute, right, obtuse, and a straight angle. And again, hopefully these sound familiar. An acute angle is less than 90 degrees. I always think, oh, it's so cute, it's so tiny. It's less than 90 degrees, okay? A right angle, you're gonna notice, has that box in there. And just be careful because a lot of times people will try to throw you off or problems will try to throw you off by making it look like an L. But if they don't put that right angle in there, we can never assume that it's 90 degrees. So it's only 90 degrees when it has that box in the angle, okay? Obtuse is going to be greater than 90, but obviously less than 180. And a straight angle is going to represent a straight line, which is 180 degrees. So we're not going to use a protractor because I'm not sure if you guys even have one of those at home. But when you're ever asked to use a protractor, I want you to estimate, okay? So for example, this question, I want you to roughly draw 138 degrees. So you're always gonna start by drawing your straight line, and 130 degrees would be past 90. So I don't wanna go straight up, I wanna go a little bit more, and that would be 130 degrees. 52 degrees, I always start by drawing that straight line, and then 52 degrees is going to be less than 90. So I'm going to say probably like this. I probably should have done a little bit wider, but that's fine. It's a good enough estimate. So even though the question says use a protractor, that's how you guys are going to solve those types of questions on your homework. Here's for some more vocabulary. We have an angle bisector. An angle bisector is a ray that divides an angle in half. So in our last section, 1.1, we learned what a segment bisector was. That divided a segment in half. Well, an angle bisector divides an angle in half. So here's how it looks. Let's say this is my angle, and this right here would be my angle bisector. The dashed line is the angle bisector. So it's a ray that divides the angle in half. Okay, and basically this, This angle here would be the exact same measurement as that angle there. We do have an angle addition postulate. Angle addition postulate means that, let's say, for example, I have line segment angle PQR. And I have this additional ray in the middle that's S. And what this tells me is that the angle PQR is the same as this PQS, which is this angle here, added to SQR. So sure enough, if I take that angle and this angle, it will make the overall angle of PQR. So basically just adding two angles together to get the whole. Let's go ahead and apply that theorem to this example here. So we have HGF. I personally, when I'm given these types of questions, like to go ahead and draw. And I'm not sure if I can do different colors. I'm going to try, probably mess up, but oh, good, I can. Okay. So I know that HGF, this entire thing here, is going to be 16x plus 4. So I'm going to write it really small. Okay. And I know EGH, EGH, I'm going to make green. EGH is going to be this one here. That is equal to 110 degrees. And my last one is going to be HGE. Oh, I'm sorry. I messed up already. Darn it. Okay, let me erase that last one. No, I can't erase it. So scratch, scratch. Okay, let me replace that. This one here in blue should be 3x plus 11. And then EGF, not H. So EGF, let me go back to my green here, is 110 degrees. So over here, this section, I'm going to do 3, is 110 degrees. So the red section represents the entire angle. The green section only represents this section, and the blue only represents this one. So by the angle addition postulate, I know that I can add my green section and I can add my blue section because those are both pieces of the angle, right? To equal the entire angle, which is my red section. And now I have an algebra problem that hopefully you guys can solve really quickly without any review. But just in case, we're going to combine like terms. 110 plus 11 is going to be 121. And then I'm going to, I like to put my x's together. There's more than one way to do this. However you feel comfortable in solving. Feel free to pause the video and solve and then check your answer with what I get. And then I'm going to subtract 4 on both sides. And I'm going to get 117. And then to get x by itself, I'm going to go ahead and divide by 13 on both sides. And 117 divided by 13 is going to give me 9. I'm going to go back and reread the question. It was asking me to find x, so x equals 9 is the correct solution.